Hi, everyone. It's Kali Arevalo, editor of Institutional Investing in Infrastructure. Here with me today is Alex Stoewer, the CEO of Greenlight Data Centers. We're going to just talk about the hallmarks of a successful data center project in the current environment. So, first off, thank you, Alex, for joining me. Let's just go right into it. So, what are some of the top considerations when constructing AI-ready data centers?
Yeah, there's a ton that goes into it. I think the one thing to keep in mind is that AI-ready data centers are pretty different from most of the data centers that exist in the country right now. So if you think about just the density levels of existing data centers, they run at 10, maybe 15 kilowatts per rack. If you think of a rack, it's something like the size of a refrigerator. AI data centers run in some cases at over 100 kilowatts per rack, so 10 times as dense. And what that means is that the existing data center footprint that exists right now can't really accommodate the AI computing that's being built. So all these NVIDIA chips that are being produced, the other high density chips that are being produced, they've got to go somewhere, and they can't go to the old data centers. The other reason they can't go to the old data centers is because those are full, but we can get into that later. So you need to make sure that you're designing your data center for high density. That means different types of cooling. That means having a plan around how exactly you're going to get the heat away from the chip and then get the heat rejected out into the atmosphere. It means that you have to have floors that can take greater density. It means that you need to have enough power available where you can't necessarily build a 2 megawatt or 5 megawatt data center anymore. It's got to be in the tens of megawatts, if not the hundreds of megawatts, and finding places where that's available is tougher.
From a development perspective, what are some of the biggest challenges that are keeping data center projects from reaching completion?
There's a lot of different reasons that deals die. I mean, the vast majority of data centers that people try to develop at some point aren't going to make it for one reason or another. And it has to do with a lot of different reasons. I think the big one right now is power. People just don't have the same access to power that they thought they did. The traditional playbook for developing data centers was let's go where the end users want to be, which is going to be in the main data center hubs. It's going to be on top of the fiber lines. It's going to be in these nodes where there's a ton of computing that's physically very close together. And let's buy land there, and then let's go and see how long it's going to take to get power. And maybe in a few years, we'll be able to build a data center. Well, now that's not a few years, it's like 7 years or 10 years or even more. I've heard that in the Phoenix area it can now be as long as 2040 to get a firm interconnection to go and build a big data center. So getting access to power early is critical. And that's what we're doing at Greenlight. We're really all about being a power first data center developer, where we go and figure out where there is power available and we go and build data centers there. Once you know you've got power available and you know on what timeline it's going to be delivered, community engagement is obviously critical. I think there's more and more pushback against data centers as they're in the news more. And I think people don't have a good understanding of what exactly is getting built. They think that they take away all the water from a community. They think that they make a ton of noise. Not always the case. And I think it's the data center operator's job or the developer's job to educate the community on exactly what is going to be built there, what it's going to look like, what it's going to bring to the community, what it's going to ask of the community. And I think in places where either the developer doesn't do a good job of that, or the area just already has too many data centers and doesn't want another one, that can certainly kill a deal as well. And then you've got all the other stuff that goes into any big development, like environmental studies and archaeological studies and endangered species, you running other types of utilities to the site, easements. These are all things that could significantly delay or even kill a project. And that's something that you just need to work through as a site developer. So I think that people, when they think of developing data centers, they think of like, okay, you go buy a piece of land and then you hook it up to power and then you go and figure out what the construction's going to look like. There is as much as a year of work or sometimes more that goes into just making sure that the site that you've bought can actually be used to build a data center in the timeline that you want it to be used to build a data center.
And it seems like a lot needs to be sort of in place before you can deliver a project like this. I know you mentioned getting the power lined up, the community engagement. What other elements of a project do you think need to be in place before capital is even deployed to ensure success?
I think that when you say capital being deployed, it's really important to look at the nuance there of how much capital is being deployed and how fully committed is that capital, or is it there a possibility of getting some sort of refund if it turns out that the data center doesn't work out? So we think about this as really there are four phases of capital that goes into building a data center. The first one is getting control over the land. And that is, it's a relatively small amount. We obviously do a whole bunch of DD ourselves before we go and spend money on land. But once our own in-house DD checks out, we're willing to spend an amount of money on going and getting control of land. Once you know you have land control, then you can start spending a bit more money on all these DD processes that I mentioned, some amount of engineering, community engagement, things like that. That can get to be relatively expensive. You know, six figures can be sometimes seven figures. For a really big data center, it could be more. But for the data centers that are in the size range that we're looking at, it's going to be 6 to 7 figures. That is something that you spend over the course of maybe up to a year, and it's really soft cost. You're not putting any money into the ground. At that point, once you're satisfied that the site can really be built out as a data center, then you may have a significant deposit to make with the utility. By the time you're spending that amount of money, you've got to be very sure of the timeline that you're going to be able to develop a data center there. You don't want to invest that kind of money and have it be non-refundable, and then ultimately have to walk away from a project or have a project get delayed by 5 years, which could kill it anyway. So you need to really have your DD built up by that point in time. The final stage is the big one, which is actually building the data center. And that's where you're spending on the order of $10 million per megawatt. So if you think about these hyperscale data centers, people talk about a gigawatt data center. Well, a gigawatt data center that is a gigawatt of IT load, that's going to be probably over $10 billion just for the building itself. I mean, that's going to cost you way more than it would cost you to build like a skyscraper in Manhattan or something like that. We're building data centers that are between 20 megawatts and 100 megawatts. So still a very significant investment. You're still talking about 200 million to a billion, but smaller than what you see the big headlines for. And I think within the range that a lot of investors are interested in putting their money to work in a not quite as concentrated way.
Yeah, sure. Thank you for touching on all that. Earlier, you mentioned that some markets are seeing longer wait times for power. Are certain regions or markets more optimal than others for data center development in general? And what are some characteristics of a successful project there?
Yeah, absolutely. I think a lot of the country doesn't realize that there's a shortage of electricity. There's a shortage of electricity being produced at exactly the right time and delivered to exactly the right place. So there's a lot of wasted renewable energy in this country. There's a lot of renewable energy that could be produced, but they actually curtail the generator, which means they either freeze the wind turbines or they run the solar power into the ground because the grid in that location can't actually handle any more power coming into the grid. Power prices go negative a lot of the time, where power producers will sell power to the grid at the price of, call it, negative 10 or $15 per megawatt hour. And they'll do it because they're getting a production tax credit that's equal to $27 a megawatt hour. So they're actually overloading the grid because it's economic to do so. We look for locations like that where there's actually a lot of excess power available, and locations where there aren't already a ton of data centers. We do want places where there is some data center footprint, but we don't want places where they're already overloaded with data centers and all the power has been used up. And we're finding that really the Midwest, Texas, some of the South, are places where you have these characteristics in place, where there is an abundance of power available. The co-ops and utilities can give you access to power delivery, maybe not immediately, but within 12 months or 18 months, less time than it takes to build the data center itself. And the transmission upgrades are mostly non-existent. The distribution upgrades, meaning substation upgrades, are relatively affordable. And that's something that we focus on, is trying to find these locations where you have near-term access to power without a whole bunch of money that needs to be spent on upgrades, and being able to energize a data center very quickly, because we see that there's a massive demand overhang for energized rack space for AI density data centers in the next few years. We think that the only good way to meet that is by being a bit more nimble, building relatively smaller data centers in locations where there's already plenty of power available.
That sounds like a good strategy there. Uh, so just one more for you. What type of approach can help de-risk infrastructure projects from the outset?
It's a big question. I think there's a lot of ways to answer it. I think the biggest one right now is making sure that you have access to power before you start spending a bunch of money on the land or on DD or on other things. That, I think, is the biggest reason that projects are not going forward or being delayed, terminally delayed. But otherwise, I would say just identifying what are the big red flags that are likely to exist in a given area, whether that's wetlands, whether that's endangered species, whether that's community pushback and zoning change, things like that. Trying to address that first before you go and spend a whole bunch of money on other stuff, because it can be the case that you get some environmental finding or some, city council that won't change zoning, and you actually just can't build anything on the plot that you thought you were going to build on. So these sort of fatal red flags are ones that you want to get out of the way early, and then you can spend a bit more time trying to maximize the value of the site, working on things like getting the best incentives and things like that don't necessarily kill a site, but could just make it more valuable.